Up to this point, we've done 3 examples of showing that things are subspaces of other vector spaces. We're going to look at some examples where you have a set H and it's not a subspace. So how would you disprove that something is a subspace? Or how would you show something that is not a subspace of another vector space? Well, that's what our goal is. So first of all, we have a problem. We have H is the set of all x, y, so we're talking about elements in R2, right? Elements in R2, they're x comma y, such that the x coordinate, its absolute value is less than or equal to 1. So what we want to do is disprove that such a set is not a subspace. So in these cases, we're going to be able to illustrate this pretty well. So here's my x-axis, here's my y-axis, right? We're in R2. We're in R2, we're living in R2. We want to prove that H is not a subspace of R2. So let's think about H. I'll do it in red. So it's all the xy points, all the points, xy, where the absolute value is less than or equal to 1. So think about the absolute value if it's less than or equal to 1. Just think about that. The absolute value less than or equal to 1, that's equivalent to, right? Logically equivalent to x being between 1 and negative 1. This is something you would have learned in like a basic calculus course. Algebra course, really basic algebra course. So here I find negative 1 on my x-axis and positive 1 on my x-axis, and we're restricted between here. And notice I'm putting a solid lines, and that's because x is allowed to be equal to those, right? It could be equal. Now y has no restriction, so y can go up and down. So basically we're talking about this strip here between negative 1 and 1 on the x-axis there. So this whole entire strip is the set H, this whole entire strip. That varies between x equals negative 1, x equals positive 1. All right, now this may give you some inspiration, So what we'd like to be able to do, we would like to be able to pick a vector. So maybe pick a vector. Yeah, so I mean, there are basically 3 things that you need to verify to prove something is a subspace, right? 3 things. You have to show the 0 vector is in there, number 1. Number 2, you have to prove if you take 2 vectors and add them together, then their sum has to end up in the set. And number 3, you have to be able to prove if I can take a vector in the set, if I take a vector in a set and I scale it by a number, the scaled version of that vector has to be in the set. So it's pretty clear that the 0 vector is in there, right? The 0 vector is in there right here at the center. So we're not going to disprove it by showing that the 0 vector is not in there, right? The 0 vector is definitely in there. But what we could do, we could take this vector right here, which is what, 1, 0, and we could scale that by 2. And if you scale it by 2, think what happens when you scale that by 2. 2, 0 would be out here, right? It would be outside of that set. So that's our strategy. So we're going to prove here, a little proof, which is a counterexample. We're going to say let U be the vector 1, 0. Now 1, 0 we know is actually in H. Why is it in H? Well, when you take the absolute value of 1, right? The absolute value of the x coordinate right here, right? The absolute value of the x coordinate is less than or equal to 1. Yep. Here we are. 1, 0. That's this vector right here. I'll call that U. It's an element of H. Now, we're going to scale that by a factor of 2. Let's go purple. So let's say note 2 times U. 2 times U is going to be what? 2, 0. Now that's not an element of H. So you look at a picture here, here's 2 times U right here, right? 2 times U. 2 comma 0. That lands out here, right? Outside of H. So this is not an H, right? I write this element of in a slash sign, right? It's not an H. Since, if you take the absolute value of the x coordinate, right, the absolute value of 2, it's not less than or equal to 1. It's actually bigger than 1. Now, there you have it. So what we've done, we've shown that one of the criteria do not hold, and particularly, in particular, the third criterion doesn't hold, right? When you scale a vector, it doesn't end back up in the set. So, therefore, because we fail to satisfy criteria 3, since criterion 3 is not satisfied, H is not a subspace of R2. It's a subset of R2, right? It lives in R2, but it's not actually behaving like a vector space. Okay, so that's one example where we don't actually have a subspace, you just have a subset. Let's do another example. Okay, let me call this big 2. Let's look at this situation. Show this H. H is going to be the set of all x, y. So ordered pairs such that x minus y equals 1, and x and y are real numbers. So we want to show that this set H is not a subspace of R2. So this is another one where you can draw a picture, right? Where in R2, our H is going to be somewhere in R2, an x-axis and a y-axis. So we're talking about all ordered pairs that take on the form x minus y equals 1. So let's see, we have x minus y equals 1. If you added y to both sides and subtracted 1 from both sides, you have what? X minus 1 equals y. And this is just a line, right? So we have all ordered pairs that satisfy that equation. That's called a line. So look what you have. You have a y-intercept here of -1, right? This is our y-intercept, -1. And it looks like I have a slope of 1, right? The number in front of the x is a 1. So I'm going to go up 1 and over 1 to find an additional point. And I'll connect those to get my line, right? And this is H. This is H right here. It's the set of x, y values that satisfy the equation of the line. So it's the line, literally. All right, so in order to show that this is not a subspace of R2, you have to show that one of those 3 criteria is not satisfied. So you could think about, okay, if I take a vector in that space, or if I take a vector in that set, and I scale it, well, I still have a vector in that set. So let's think about that. Let's say I had a vector here, a yellow vector here. If I scale it either positive, it's just going to get bigger and stay on that line. If I scale it negative, it's going to go in the opposite direction. So scaling is not violated. What if we take 2 vectors and add them together? Let's say I had a green vector here on that line, and then I had another blue vector here on that line, and let's say I add them together. So I'm going to go, let's see, I'm going to go forward on the green, and then I'm going to go back on the blue. Yeah, I'm still going to end up on that line. However I add my vectors, I'm going to end up on that line. So that's not the problem. The problem here is the zero vector does not live inside of this space, right? The zero vector, where is the zero vector? Zero vector, I'll put in purple. It's somewhere off to the side. The zero vector's over here. So that's the problem. So, I mean, you can see the problem very clearly. Let's actually do the proof now to prove the zero vector's not here. How do you prove the zero vector's not here? Let's say proof. So, let's say note 0, 0, that's the zero vector, is not an element of H. Why? Since setting x and y equal to 0, x equal to 0 and y equal to 0. So let's say I plug in 0 for x and 0 for y. That does not satisfy the equation x minus y equals 1. So that was the equation, if you remember, that had to be satisfied for h, right? H had that equation x minus y equals 1. Notice that if I plug 0 in for x and 0 in for y, the equation's not satisfied, right? You get 0 on the left and 1 on the right. So that's the problem there. That's the problem. So since the zero vector is not in H, right? We have the zero vector is not in H. We're in trouble. We're not a subspace. So since the first criterion of the subspace test is not satisfied, then H is not a subspace of R2. That's the end of that. All right, let's do yet one more example. What do we want to do here? Okay, let's say we have a set H. Show H that takes on the form all ordered pairs x, y, such that, let's say, y is greater than or equal to 0 is less than or equal to x. If x is greater than or equal to 0, and x is less than or equal to y, it's less than or equal to 0 if x is less than 0. So show that this set H is not a subset of R2. I'm sorry, not a subspace, not a subspace. Subspace. All right, let's try to draw a picture here. Let me do my x-axis and my y-axis first, just to get an idea. So if you focus on the first set of inequalities here, this is when x is greater than or equal to 0, right? X is greater than or equal to 0. Now, what does the equation y, let's say y equals x look like? All right, y equals x. Y equals x is just a diagonal line. So we have y equals x as an upper bound for our region. This is when x is greater than or equal to 0. So x is positive, right? Positive. So that's going to be over here on the right-hand side in the first quadrant and possibly the fourth quadrant. But we have that y is actually less than or equal to x, right? y is less than or equal to x. So let's make our color a little bit different here. So this is just a boundary we have so far. So let's look at y less than x. That would be this part here, right? Y is less than x. So that would be down here beneath y equals x. But then, as a lower bound, it's like we have y equals 0 here, right? Y equals 0. That would be this horizontal line right here. And also we have that y is greater than 0. So y has to be above that line y equals 0. So we have this region here when x is greater than or equal to 0. So that's here on the right, this direction. And the x values are positive or 0. So that's part of what we have. We have this over here. Now if you look at the second part, in the second part, I guess we can use a little green for that, or no, maybe you use blue. This is when x is negative, right? When x is less than 0. So when x is less than 0, that's the second part. So it's going to be to the left. That's going to be in the left-hand side. So first of all, y could be equal to 0. So that's going to be an upper bound, right? Y could be equal to 0. So that's this line right here. Or y could be less than 0. What color are we going to use for that? Let's use kind of a bluish color. Y could be less than 0. So this is right here. Y is less than 0. So that would be down here. Now, if we think about y equals x, that's going to be a lower bound here, right? Y equals x. Y equals x is just the line right here, right? Just that line. Continue, that diagonal line. So it looks like I've done a little bit too much shading here. I need to get rid of some of that. And also we need to mention that y is greater than x as well, right? Y is greater than x. Y. Let me get the right color. Y is greater than x. So here's y equals x, that diagonal line. So y is greater than x would be up here above. So we're shading in between y equals 0 and y equals x. So we're talking about this region. So our H consists of these two regions collectively, union together. So let me go ahead and put it all in purple. Well, that'd be nice. Be fantastic if this worked. This is H. This kind of dark purple, kind of violet color. So it includes the x-axis. It includes the diagonal line y equals x. And it includes the regions in between the diagonal line y equals x and the x-axis. Okay. So that's H. Now, do we have any problems with any of those three criteria? Any problems with those three criteria? Well, we definitely have the 0 vector, right? The 0 vector, I'll actually put that in yellow. So we don't have a problem with the 0 vector. Do we have a problem with scaling vectors? So let's say I were to take like a green vector here, and I were to scale that. Positive would just go forward more, get longer. Negative, and flip it around and go in the opposite direction. So I don't think we have a problem with scaling. So the problem must be somewhere with the adding of two vectors. Well, can I come up with two vectors maybe that fail? maybe two vectors that fail. I think I can. Two vectors I add together and that don't up in H. Well, let me get rid of that. Okay, come on. Nope, nope, nope. Okay, you're going to work this time. Okay, so I'm going to erase all this chicken scratch here. Chicken scratch. So we want to come up with two vectors that fail. So we're going to do a little proof and show that we're going to come up with two vectors that are both in H, but when you add them together, they're not in H. So here's an example. Let's say let's pick a U vector, 3, 0. That's definitely an H, right? Think about where 3, 0 is. 3, 0. Let me do a little erasing here. Yeah, I'm losing it. Losing my pretty colors. Okay, I'm back to shading my region again. Okay, so I picked a U, right? 3, 0. It's somewhere over here. It's my U vector. Now that's definitely an H. Why is that an H? Well, let's not look at the picture so much. Let's focus on here, this top equation, right? So the y-coordinate, which is 0, is smaller than the x-coordinate, which is 3, since 0 is smaller than 3, right? So your relationship is that the y-coordinate here, right, y should be less than or equal to x. And that's what I have. My y is 0. That is less than or equal to my x, which is 3. And so we got u to be 3, 0. Let's come up with the v. I pick my v to be -2, -5. Now it's -2, -5. Is that an H? I'm going to say, yeah, it's an H. Why? Why is it an H? Well, when you're dealing with negative x values, right? When you're dealing with negative x values, the x value should be smaller than the y value. So if you look at my x value here, what is my x value? Oh, let's make that a -7. -7. How about -7? Since -7 is smaller than -5, yeah, right? -7, 5 is an H, so where would -7, 5 be? -7, 5 would be, let me think about that for a second. Be somewhere like here, right? You go -7 on the x, -5 on the y, be somewhere out here. Now, let's add those two vectors together, u plus v. So let's note that u plus v, what happens when I add them together? I got 3 and -7 is -4. 0 and -5 is -5. So note that this vector is not an H, not an element of H. So how can we guarantee that this is not an H? How do we know that this is not an H? So in order to be an H when you're on the negative side over here, the x was supposed to be smaller than the y, remember? The x was supposed to be smaller than the y. So the problem is that -4 is not smaller than -5, right? -4 is greater than -5. So in reality, you took this vector u, let me do this in yellow now, and then you had this vector v over here, and you took u plus v, well, maybe like that, and when you did that, Come on, yellow. When you did u plus v, you got a resultant vector here. That would have been u plus v. And that resultant vector, u plus v, is definitely not in H. All right. So what are we going to write? We're going to say, since criterion 2 is not satisfied, since criterion 2 of the subspace test is not satisfied, then H is not. Come on, erase. Come on. H is not a subspace of R2. That's that.